Let's discuss parallel lines. So what are parallel lines? In simple terms, parallel lines are those which have the same gradient. Which have the same gradient. For example, gradient of this line is 2. So if the second line is parallel to the first line, it has to have the same gradient, right? So if two lines are parallel, so one thing is common, that the gradients are exactly the same, right? Let's take an example. For example, let's say there is line A and it has equation of y is equal to 2x plus 3. And there is another line which passes through point 5 and 2, right? So this is line B. So you have to the equation, find the equation of line B, right? So we have to find the equation of line B. And both the lines are parallel. So when the word parallel comes, the first thing that should strike your mind should be that the gradients are exactly the same. They have the same gradient, right? So if you have the gradient of the first line, that means the gradient of the second line is also the same. So again, we have to see that the equation has to be in the standard form. Please remember that. If the equation is not in standard form, we will convert that in standard form, and then whatever is the coefficient of x, that would reflect the gradient of the line. So let's see. So when we look at this equation, yes, this is in standard form. What do you mean by standard form? Y should be the subject and the coefficient of y should be 1, right? So y is the subject and obviously a coefficient of y is 1. So whatever is the coefficient of x, that gives you the gradient. So the gradient of this line is 2. So because this line is parallel to this line, so the gradient of this line would also be 2, right? So we got the gradient, we got a point on the line. It's pretty simple. Just plug in the values. Y is equal to mx plus c. So because this point lies on the line, so this point would satisfy the equation, right? It would, the x and y coordinate will fulfill the equation. So we'll plug 5 in x and we'll plug 2 in y, and let's evaluate c. And we have the gradient. So y is 2 and gradient is again 2 and x is 5 plus c. So this is 10 plus c, and you'll subtract this, and c is minus 8. So you've got the gradient, you've got the y-intercept, so just plug in the values and you'll get the equation of the line B. So equation of line B would be, equation of line B is y is equal to mx plus c, and just plug in the values. The gradient is 2 and y-intercept is minus 8. So this is the equation of line B, which is parallel to this line y is equal to 2x plus 3, and it passes through the point 5, 2. So I hope this is pretty clear. Let's take a look into another example. Right. Let's have a look at the second question. So we have a line A and it has equation 2y plus 3x is equal to 1. And we have a parallel line to line A and it is passing through a point minus 3, 2. And obviously we have to find the equation of line B, right? So both the lines are parallel. So the first property that should come to your mind is that the gradient of parallel lines is exactly the same. So if we could find the gradient of line A, that would automatically be the gradient of line B. So let's try to find the gradient of line A. So first thing is first, we have to write this in the standard form, y is equal to mx plus c. Unless and until we make y the subject and the coefficient of y is 1, we cannot tell what is the gradient of the line, right? So let's try to make y the subject, right? So let's write the equation. Let's shift x on that side, right? And we have to make y, the coefficient of y 1. So let's divide the whole equation by 2, right? So I'm dividing the entire equation across the board both sides by 2, right? So when you divide this by 2, this 2 gets cancelled out. And when you divide this term by 2, this comes out to be minus 3 over 2x, and this would be 1 over 2, right? So now this is in the standard form. Y is equal to mx plus c, and you made y the subject. So what is the gradient? The gradient is the coefficient of x. So the gradient of the line is minus 3 over 2. So the gradient of the line is minus 3 over 2. So since both the lines are parallel, hence the gradient of line B will also be minus 3 over 2. I hope this is pretty simple. Now you've got the gradient, you've got a point on the line. So again, standard, we'll apply the standard concept. So what is the standard equation of a straight line? Y is equal to mx plus c. We've got a point on the line, so it would fulfill the equation of the line. So we'll plug in minus 3 in x, and we'll plug in 2 in y. So let's do that. The gradient is minus 3 over 2, and x is minus 3 plus c, right? So this is 9 over 2 plus c, right? So let's subtract this. So this becomes minus 9 over 2 is equal to c. We have calculators. We can also calculate with a calculator. But anyway, let's take LCM. So this is 2 and this is 4 minus 9. So c is minus 5 over 2. So this is your c, right? So we've got the gradient. We've got the y-intercept. Simply plug in the values in n and c, and you'll get the equation of line B. So this is again y is equal to mx plus c. So y is equal to minus 3 over 2x, and c is minus 5 over 2. So that is your equation of the line B. So I hope it's very simple and you've enjoyed the topic.